Hey y'all. Hey, the other day I was showing you this rock that was being overtaken by silicone. I've learned quite a bit since then, and I want to share that with you. So if you just give me a moment, I'm going to switch this around for you. Okay, here we have a unremarkable small piece of sandstone. It's you can tell it's sandstone partly because it's layered, although I can't really see the layers in this. It just looks like a hunk of sand. But anyway, one of the things that's unique, or not unique, but common in sandstone is that it has a very rough, porous surface. For example, you could not put your finger on there and pull it off and then pull a fingerprint off with a piece of tape. You might be able to with some other methods, but I'm not a cop and I'm not familiar with all those. And I know that's just one of the characteristics of sandstone. Now let me show you another piece of sandstone, or what used to be a piece of sandstone. Now you can tell that by it is layered. It doesn't show up really well. I mean, I'll lick it for you. You can see there are layers in here. Here's more, even better. I'll try to bring a bottle of water next time. You can see this layered. Also, though, notice that it is not rough in texture. It is extremely smooth. In fact, you could easily pull a fingerprint off of this thing with a piece of tape. Now, the difference in this between this piece of sandstone and that other one that I discarded is that this has undergone a process called silification, and that's when silica crystals grow and completely overtake the object that there are within. This is exactly how most fossils are made, if not all. I'm not 100% sure on that one. But I just learned that actually happens to rocks. There is no more sand in this rock. It is a complete hunk of chalcedony, or actually colored jade, if you want to be technical. Now, here's another example. And this one is really cool. And you can see how, first of all, it's very smooth. You can also see how the chalcedony has, like, not only taken over that rock, but continued to grow. And I like this rock because it's got this really bright red splash of ferric iron. That's a ferric iron deposit, banded iron. This is a banded iron formation. So I thought that one was really cool. And then on my way over to film this, I found this one. It's another banded iron formation. It's red, and it looks like it's partially undergone silification. It's like really super hard, and it does have pores, but it's not crumbly porous, you know, like you could wipe material away. Anyway, I thought it was really pretty. Put some color on that thing for you. All right, I got one more, and then I'll quit wasting your time. And that is this one. I was talking about it the other day, and this is before I had learned about silification and read up on that. And what this most likely was, I don't think that the rock, because the silica crystals absorb the rock basically and dissolve it and take it over. I don't think these bands of crystalline growth caused this rock to fracture. What I think happened is this rock got exposed to the environment before the silification process was complete, and the rock just eroded and left the crystals. That's probably what happened. So I was a little bit mistaken on that, and I was unaware of silification, and I wanted to share that with y'all. So I hope I've redeemed myself, and y'all have a wonderful day. Keep looking down, you never know what's underneath.